Hey, we're doing topic 2.7 next. We're looking at what are some more properties of exponents. What can we do with those exponents once we're working with them? So our I can statement, I can write a number with a negative or zero exponent. We can write it in a different way. What that means though is like if I've got a zero exponent, so exponent is zero, as long as a is not equal to zero, so it can be any number, just not zero, then that is going to equal 1. So any number, no matter what it is, if it's got 0 as the exponent, it's going to equal 1. The marker's really nice right now, really dense in that color. Negative, that just turns it into a fraction. So if I've got a to the negative n, so any number, again, that is not 0, that is risen to a negative exponent, we can just flip it, put a 1 over top of it and get rid of that negative. So a to the negative n, we just flip that and we go a over a positive n, a regular n. And we've got our exponent flipped there. Okay? So that's our key concept. We can use additional properties, that's 2 of them. Zero exponent, the exponent of 0 means it's 1. A negative exponent, you just write it as a fraction underneath 1. Oh, that's dirty. So let's do some practice ones here. Calvin and Mike do sit-ups when they work out. They start with 64 sit-ups for the first set and do half as many each subsequent set. So what representation can we use to show that relationship? I'm going to do a table. So if I do a table and I go like this, so with set number 1, they did 64 sit-ups. With set number 2, my marker's dead, so I'm not going to do the horizontal lines there, but with set number 2, they're going to do half the number, so half of that is 32. Set number 3, they're going to end up doing half of 32, which is 16. Set number 4 is going to be 8. Set number 5 is going to be 4. 6 is going to be 2. And set number 7 is just 1. So how do we represent that? Well, each time we were dividing it by the number underneath there. So if we do 64 divided by whatever our number is there, that's a way we can think about that. 64 divided by n, where n is the set number that I want. So what conclusion can we make about that? 64, I'm just going to read what goes there, because again, I don't want to use this marker so much. It's not erasing very well. So 64 divided by the set number is going to equal how many sit-ups they do in that set. Example number 1, we're going to look at that 0 property. So Mashella is playing a card matching game with some classmates. 4 matches have been made. She chooses the next card that she's going to flip over. What card does she need to hope she flips over to match 3 to that 0 property? So the 0 property of exponent says that if I've got 3 to the 0 exponent, that is equal to 1. So I need to find, if I'm going to flip over one of these 7 cards, I need to find, or hope that I find the number 1. Simple one there. Number 2, negative exponent property. Simplify the expression. So if I've got 4 to the 3rd divided by 4 to the 5th, I can, hold on you guys, I'm recording. I can subtract these here. So if I do 3 minus 5, that turns into 4 risen to 3 minus 5, which turns into 4 to the negative 2 power. Now that negative exponent rule said that when I've got a negative exponent there, I can turn that into 1 over that number, with a positive exponent. And then number 3, expressions with those negative exponents. Again, it says write the expression. We got 1 over 7 to the negative third. Now, because it's written with that negative exponent, I can do the opposite of what I just did up here and get rid of that fraction. So that's going to become 7 to the power 3. Simple there.